Greetings, beloved students. I trust that you're well today. I apologize that I'm not able to be with you in person, but we want to make sure that this video can be close to perhaps the next best thing. Listen, very, very important. Even though I'm absent, you must still treat today as a day of learning. It could be possible that at some point during the lesson that you have a tendency to say, I don't know what's going on, but you're saying that just because I'm not here. Be careful, okay? Even if that pops in your mind, let's try to move forward from there. Honestly, I'm going to be allowing you to experience the same thing you would experience had I been in the classroom. Now, the choice is yours. You got to seize it. There's going to be a couple places in the video where it stops, and I'm going to ask you to record your thoughts. These would have been the same places that I would have had you turn to your neighbor and share something, or perhaps try to write something down. Again, you really got to move forward from that tendency to say, well, I don't know. But you may not have known when you were sitting in the classroom, but you would have tried. And you probably would have tried because I was encouraging you. Maybe your neighbors were trying. Same thing. Okay, so are we ready? All right, set. Here we go. Actually, the first part of today's lesson is a little mini lesson that you are going to teach yourself. Of course, you would have taught yourself had I been here. It's a little extension, so that means that it uses some ideas that we've been talking about, but now you're going to extend on them a little bit. I'm going to ask you basically to take probably about 5 to 7 minutes and do some reading. You can write some stuff down while you're reading if you want, and then you're going to be prompted to answer a couple questions. It's on the link that is also in your post, so please at this time click on that link, open that up, and you're also going to want to pause the video. Okay, because after you unpause the video, the next thing that's going to happen is it's going to prompt you to record some answers. Yes, I want you to try to record some answers after you do this reading. And yes, we will go over it. All right, so ready? Pause the video. I'll meet you back here when you're ready to record some answers. That'll be the next spot in the Ed puzzle. All right, well, how did you do learning a little bit about undefined trig values? Ultimately, when there's a zero in the denominator, it's going to be undefined. We know that. But do we realize that these trig functions are all defined by fractions? And so, of course, since we have fractions, we have denominators, and we have the possibility for a zero in the denominator. So the tangent of 3 pi over 2. Now, let me just mention, perhaps you worked through this already, but it's a common mistake for students just honestly to misinterpret 3 pi over 2. If you were thinking like this at some point, it's a common mistake, but we want to move away from it. If you were thinking, okay, y equals 3 pi and x equals 2. No, that's not true, because actually 3 pi over 2 is an angle. And I know it's a new kind of angle, but we want to understand it's an angle in radians. Now, where is that angle? Well, you could look it up from the first, second day of school when we started talking about those kinds of rotations. Or maybe you now know that 3 pi over 2 is this rotation. This point of intersection right here, of course, is of the utmost interest. Now, since this is on the unit circle, wait, what did you say? I love the unit circle. I thought I heard somebody say that. But since this is on the unit circle, that point of intersection is very knowable. It's 0, -1, and of course, that's our x and our y. Just by the way, the r value is always equal to 1. That's not actually needed for this particular trig function, but just saying, r is equal to 1. We're on the unit circle. I know, you love it. And since tangent by definition is y over x, then we're ready to record our value. Of course, y and x was this point, given as -1 over 0. So this one definitely was undefined. And that's the reason why. How about the tangent of 180? What did you say about that one? We're going to have to rotate to 180. It's, of course, a little easier to know. That point of intersection, again, being careful, is -1, 0. And tangent is still by definition y over x. So again, here's my y and x value, 0 and -1. That is not undefined. In fact, it's defined to be 0. How about the cosecant of 2 pi? That's right, that one's undefined. Did you get it for the correct reason? Let's go through it quickly. There's 2 pi, that's kind of rotating all the way around. Our point is of utmost interest. Of course, that's the value 1, 0. Cosecant, are you getting to know those definitions? Get to know them. You have to ultimately have them memorized by the time we have our test. Yes, that test is about a week away, but cosecant, by definition, is r over y. And this time we do need the r value. So just kind of going back to that reminder, r is still equal to 1, in case that got you. R is equal to 1 over y. The y value is 0. And of course, that's a no. So that one's undefined. Did you come up with one on your own? If we were in class, I would pull some answers from people, but you're basically trying to come up with something with a 0 in the denominator. Something we didn't talk about was secant. If you had trouble doing this, secant by definition is r over x. So kind of working backwards, you just need x to equal 0. Well, where does x equal 0? That's right, it equals 0 at one of these two angles. And perhaps we pick the one that we haven't done yet, either 90 degrees, or in radians, pi over 2. But again, really what I did was I thought about x equaling 0, and then I kind of went from there. So the secant of pi over 2. Okay, that one's undefined because r equals 1, but x equals 0. And perhaps there'll be some other possibilities that we did not see yet. How'd you do with the second extension? The second extension, trying to understand that these trig functions are really just talking about x and y values, or perhaps maybe more accurately, y and x values when you think about the definitions, quadrant 2 that we went over in this first one. Here's something kind of interesting. Since tangent is y over x, that means it would be positive over negative. In other words, like a little fraction. So that's a good reason why that one comes out negative. So how'd you do in quadrant 1? Sine, it's just like a y value. Y values in quadrant 1 are up, so they're positive. How about cosine? It's just like an x value. X values over to the right, those are positive. This is y over x. By definition, that's the same as tangent. And positive over positive would also come out positive. This is not something that I would want you to necessarily memorize. This is something that you should be able to kind of think about. So if I asked you for quadrant 4, I'm kind of skipping down here to quadrant 4. Sine, yep, it's negative, you're down. Cosine, yep, it's positive, you're to the right. And negative over positive is still negative. That's because tangent is y over x. And how about this last one here? Quadrant 3, you're down, so sine is negative. Remember, sine is a y value. You're to the left, that's like a negative x value for cosine. Okay. Again, when we say cosine of theta, we're talking about the x value at that particular angle. And tangent would be y over x, so negative over negative. It's going to come out positive. All right, at this time we're going to kind of switch gears and get into more of the main lesson. What you guys are going to find is that we continue to talk about these trig functions, sine, cosine, tangent, and their reciprocals, and how we can also find trig values. Again, trig values are essentially just these answers that go with trig functions. Now, what's going to happen is that today's lesson relates to what we were doing yesterday, but of course it's got a new element. And instead of me just telling you how to do the problems, I'm going to use a technique where I'm going to try to get you to think a little bit. Okay, quick disclaimer again, this is the same thing I would have done in the classroom. So in the next few moments, if you're like, I have no idea, you got to move past that, okay? Because in the classroom, I would have given this to you and not let you just rest with, I have no idea. You have to think a bit on your own. So what's this slide say? Okay, it says that the cosine of theta is equal to -3/5. That's a comma after the number 5, so it's just -3/5. Now, if the cosine of theta equals -3/5, like I'm giving that to you. I'm telling you that that's true. What else can you figure out to be true? What sketch, perhaps, could you deduce? Okay, now this is kind of wide open. And again, if we were in the classroom, I would be pausing, letting you guys think about this, then probably share with your neighbor, and eventually some sharing out. So what you're going to do is pause the video. Yes, I want you to try to figure out what's true. If you're a little more of a visual learner, draw a sketch. Okay, at least try to draw a sketch. Then tell me what you came up with. All right, so what'd you come up with? Some of the popular responses would be understanding, basically memorizing that cosine, by definition, is x over r. Wait, does that mean that -3/5 is x over r? 100%, that's exactly what it means. So -3/5 is actually referring to that fraction. Wait, where should we put the negative sign? Well, we're going to learn that the negative sign is not allowed to go with the radius, because the radius is always positive. And so, that means that x is negative, specifically -3, and r is 5. Wait, x is -3 and r is 5. Can we make a sketch that sort of relates to that? Well, 100% we can. It's a sketch of a triangle. Did you try to draw a triangle? If you didn't, of course, run with it now, or compare it if you did. But basically, if the x value is negative, I know that I got to be going to the left. That's a key idea. You'll get used to these triangles. The radius is always drawn from the origin, so that leaves nothing. That leaves no choice then but to draw the rest of the triangle. That is like the y value in this position. So basically, x is -3, r is 5, and what about that y value? Okay, well, eventually it'll be something that we can find, but that's getting ahead of ourselves just a bit. Wait, what's that you say? There's another triangle that seems like it would satisfy this? You're correct. You see, this triangle, if you will, down here also has an x value of -3. Yep, the r value is still +5. R is always positive no matter where you put it. And we still have a y value, but I'm sure you can see that that y value is going to be negative. Of course, the one that we originally drew is positive. Now, all of this is true, just knowing that the cosine was given as -3/5. So what's next? Well, what's next is that I give you more information. I didn't give this to you all at once because it would have been a little overwhelming. But let's say that this statement here that's written in white, it says that the sine of theta is greater than 0. That's kind of like the second half of the given. Let's pretend that that's now also something I tell you. So now what is true? Wait, what's that you say? We can get rid of one of these triangles or only choose the triangle that has a positive y value? Why is that the case? Well, that's because sine, remember sine, this statement right here, is essentially saying that the y value is greater than 0. And so if sine is greater than 0, the y value is greater than 0, then it looks like that we can basically know this sketch to be true. So what do we do with this? Okay, well, here's the last part of the overall question. We can find some new trig values. That sounds like fun. We can find the tangent of theta. We can find the cosecant of theta. Now, that should sound a little like what you were doing yesterday, right? How you were finding these values. Okay, but of course, to find the tangent of theta, we're going to need a y and an x value. So if we go back over to our sketch, I'm just going to kind of redraw it a little more quickly here. Oops. If we go back over to our triangle sketch, we had, of course, x equaling -3, r equaling 5, and oh yeah, we could find the y value. We could kind of find that missing dimension. And of course, the Pythagorean theorem, just like you were doing yesterday, is kind of our saving grace here. So we end up with y squared. Once you do a little solving here, what? Y squared equaling 25 minus 9. And so that means that y equals, now technically y would equal plus or minus 4. But you see that I'm only going to choose the positive y value since that's what my sketch is sort of requiring. So I've got my missing dimension, and I can finish up with the tangent of theta based on those dimensions. And this answer is fine. Perhaps a little bit more fine would be to write this more wholly as just -4/3. In other words, just putting the negative out front. Can I do the cosecant? Or maybe I should say, can you do the cosecant? I encourage you to try it. You can pause the video if you want, although I am going to just go over the answer. Okay, so cosecant by definition, are you getting to know those definitions? R over y. Our r value was already given to be 5. Of course, we found our y value to be 4. This is similar to yesterday, isn't it? You're still finding a trig value. It's just that you are given a trig value as kind of your starting point. So if you're finding trig values when you're given a trig value, what you're going to want to do is ultimately you're going to want to make the corresponding sketch. Now that sketch is going to be of a triangle, and of course the place that you put that triangle is going to be very important. Okay, but you're going to make a sketch, and we'll keep talking about how to place it. Just kind of a little note here about the radius. You heard me say verbally that the radius is always positive, and you always want to draw the radius from the origin. Okay, you want your triangle to kind of be positioned so that the radius is, again, coming out at an angle from the origin. Ready to do another problem? We'll kind of call it an example, but you want to be active. You want to be thinking, okay, how would I go about this particular problem? Go ahead and jot it down. It says the cosecant of theta equals -2. Okay, that's a trig value that's given to you. It looks like theta is also given to be in quadrant 3. Okay, now honestly, there's all kinds of things that we could do with this. When you're ready, we could kind of think about what is true. You want to start with cosecant, kind of like we did in the previous problem. That's right, cosecant represents r and x. Oops, not r and x, but r and y. Okay, so we get that little definition. Wait a minute, -2. That doesn't look like a fraction. It doesn't look like it's got 2 values. Of course, until you write it as -2 over 1. Very good. Wait, the radius can't be -2? You're right. So we can take that negative sign and we can swap it down to the 1 to make the denominator -1. Okay, so just saying, from what we were given, we now know that r equals +2, but y equals -1. R equals +2, but y equals -1. Theta is in quadrant 3. Do you realize that just because you're told that theta is in quadrant 3, that you could draw your angle in quadrant 3, and more importantly, you could draw your triangle in quadrant 3. Do you see the way that I'm kind of creating this triangle? Do you see how the radius comes out from the center? Do you also see that the y value being -1 makes sense? That triangle's going down. We also have the radius being 2. So, of course, that always makes sense as long as that radius is positive. And The x value. You're right. We need to find the x value. This is a special triangle. Some of us learned how to count with special triangles. You would call this a 1, 2. What's the answer? 1, 2. That's right, root 3. So your x equals root 3. But if you weren't ready to say, wait, it's not equal to root 3? It's not. Oh, yeah, it's negative root 3. Now, what just happened right there is a big stinger in trigonometry. Basically, making sure you get your dimensions, your positive and negative dimensions, labeled correctly. How do we know that that was negative? The position of your triangle. Yes, that's in a negative x position. Okay, again, how would we know that? Well, because we drew the sketch correctly. And once we saw the sketch, we see that x would have to be negative. Okay, now, it is a special triangle. It's a 1, 2, root 3. But if you weren't ready to say that, that's okay. You could have gone back to good old Pythagorean theorem. Pythagorean theorem, I like to say it always works. Of course, it always works on a right triangle when you set it up correctly. And when you set this problem up correctly, you would find yourself solving and getting x squared to equal 3. But of course, when you square root that, you get the square root of 3. And the plus or minus allows us to kind of also sort of algebraically explain why we are able to get a negative root 3. So we're going to choose the negative root 3 out of that. Now, that was all based on the given, but something a little strange in this problem. What is it that we're actually trying to find? Well, you're trying to find a trig value, and those trig values, there's 6 of them, and I could ask you to find any of them. You know, like let's say I like cosine, and I tell you to find cosine. Well, you're ready to do it because you know that cosine is x over r, and I found those values, so I'm ready to record that. What if I asked you to find cotangent? What if I asked you to find again, I can ask you to find any of them. I'm trying to think if in your homework you got to find all 6, or if maybe you'll just find like a few. But if I ask you to find cotangent, we haven't done that one today. Remember, cotangent is x over y. So I could record negative 3 over 1, or maybe just negative root 3 over 1, or just negative root 3. So the sketch is important. And basically, the quadrant where you draw your sketch, that's going to help you determine which dimensions are positive and negative. Okay, that's something you got to work out. You're going to come to realize that the sketch, the place that you draw your sketch, it matters. Okay, but you're going to figure that out based on what is given. Are you ready? I'm going to ask you to do a problem on your own here. Okay, yep, I want to see if you can do this from start to finish. What's happening here is I'm telling you that the secant is equal to root 3. So that's a given. And sine is less than 0. That's also given. Can you find, I don't know, what do you want to find? Can you find, how about just the sine of theta? Okay, and all right, we'll also find the tangent of theta. Because, yeah, once you find one, you really could find any of them. All right, what's true? Try to draw a sketch. All right, so how'd you do? Secant of theta. I would start with the definition. Yep. Secant by definition is r over x. That means that root 3 should be thought of as over 1. So that the radius is equal to 3 and the x value is equal to 1. How about the sine of theta less than 0? That's just fancy talk, right? That's just fancy talk for a y value that is less than 0, or maybe to be more specific, a y value that is negative. Now, when it comes to drawing the sketch, you want to realize here that you also deduce that x is positive. Yes, that has to be true. X is positive. Y is negative. X is positive, Y is negative. We're talking about a triangle that's in quadrant 4. Okay, now when you draw that triangle, you got to make sure the radius comes out from the origin, but you got your sort of your two legs, your Y value. We don't know what it is, but we know that it's negative, and we've got this X value that we found out is positive 1. Wait, what's that? You know that the R value is root 3? Yep, you can put that on the sketch also. Now be careful. Okay, this is not a special triangle because the root 3 has to be on the leg. It cannot be the hypotenuse. So it would have been sort of unfortunate if you just quickly said 1, 2 root 3, or in this case, negative 2. It's still not right. Yeah, you got to use the Pythagorean theorem. Okay, now the Pythagorean theorem, again, I like to say it always works as long as you set it up correctly. Okay, of course, in this case, I don't know the Y value. I do know the X value, and I also know the radius. Okay, so solve that carefully, and you indeed are going to come up with root 2. Just make sure that we're getting our math right. Okay, when I subtract 1 from both sides, I'm going to have 2. When I take the square root of both sides, that's my root 2. Of course, square root always produces plus or minus, so really we should be saying plus or minus root 2, and that gives us a good reason to choose, to algebraically say that we can choose or have a negative sign there. Okay, why is it negative again? Triangle's leg, the Y value is in a negative position. It's going down. All right, so what were we going to try to find? The sine of theta. Well, I needed some space here, but the sine by definition is Y over R, and I'm pretty sure I got a Y value. It's negative root 2, and I'm pretty sure I got an R value. It's root 3. Uh-oh, we got a square root in the denominator. Did you take the time to rationalize that? It's a little tricky, but I did this on purpose so that we could definitely go over it. Your need to multiply negative root 2 times root 3 to get negative root 6. And when you multiply the denominator, you just get 3. So negative root 6 over 3. It's a good problem. How about tangent? How'd you do with tangent? Y over X, a little bit easier because there's nothing that needs simplified. I would hope that you would just write it as negative root 2. Finding a trig value given a trig value. Okay, you got to keep working this out. That's what the homework's for. We definitely will reconvene next class period, and we will continue our journey with trigonometry.